In this section, we will be continuing with the tubular functions. We will start with the loop of Henle. Okay, so we will see what are the functions of loop of Henle. So, loop of Henle is actually having three different segments. One is a thin descending limb, that is the first thing. Thin ascending limb, second part, and thick ascending limb, third part. Okay. So, here the thin descending limb loop of Henle, the cells are very simple. Okay, they don't have much important functions. In fact, they are not involved in any of the active transport mechanism of the solutes. The only thing that is freely going out of the cell is this water. Okay, so reabsorption of water is happening here predominantly. Okay, and ascending limb is not permeable to water. Whether it is thick or thin, the ascending limb entirely, they are not permeable to water. Okay, so here the thick ascending limb is very important. Okay, so the thick ascending limb is the one wherein the 25% of the solute reabsorption is taking place. In proximal convoluted tubule, 65% of the solute absorption taken place, and here in the loop of Henle, thick ascending loop, the remaining 25% is taking place. Okay, so what happens here is all the important solutes like sodium, chloride, potassium, calcium, magnesium and bicarbonate, they are getting reabsorbed actively in the thick ascending loop of Henle. Okay, but water is not reabsorbed, it is impermeable. Both the thin ascending limb as well as the thick ascending limb, they are impermeable to water, and that's why the fluid that is present inside the thick ascending limb is actually the hypotonic fluid or hypoosmotic fluid. Remember, in the proximal tubule it was isoosmotic. Here it becomes hypoosmotic because all the solutes are taken away, the water is remaining inside the tubules, so it is hypoosmotic in nature. What are the permeability characteristics of the loop of Henle? The thin descending limb, it is permeable to water, it's highly permeable to water. Little bit of urea and sodium chloride can go passively. Okay, whereas there is no active transport of the sodium happening in the thin descending limb. In the thin ascending limb as well as the thick ascending limb, the water permeability is 0. Okay, whereas in the thin ascending limb, there is little permeability of urea. Passive transport is happening in the thin ascending limb. Active transport for sodium is not there. Okay, it is 0. The thick ascending limb, on the other hand, it is predominantly important for its very active transport of the sodium, which is very, very robust there. So, the functions of loop of Henle is very importantly this presence of the sodium, one potassium, 2 chloride co-transporter channel. This transport channel is actually reabsorbing the sodium, chloride and potassium into the interstitium. Okay, so this is the prime channel that is responsible for creating the hyperosmolar gradient in the medullary interstitium. Apart from that, there is sodium hydrogen exchanger, which is actually for hydrogen ions. By excreting hydrogen ions, it reabsorbs sodium ions. Okay, apart from that, potassium channels are there, which is responsible for excretion of potassium ions. This is also happening here. Okay, and along with this transcellular transport of these substances, paracellular diffusion of calcium, magnesium, potassium and sodium also is taking place in this segment. The calcium, magnesium predominantly getting reabsorbed only in the loop of Henle. Okay, so even though all these ions are getting transported, water is not getting transported because this segment is impermeable to water. That is why the fluid here is hypotonic in nature.